There, folks. Just getting set up here. Looks like everything's good. Hopefully, we'll be avoiding technical difficulties today. The weather seems nice and cool. Connection seems strong. So I know those of you that have tuned in the past, you've probably dealt with some of the overheating that we've come across. So hope everyone's doing well out there. We're here in Carson City at the Foothill Garden. Can't tell too much, but still kind of hazy. The smoke is certainly improving, so hope everybody's breathing easy. Wait a few minutes and see if anybody tunes in. I don't have anybody showing up yet, and I don't think we have anybody here live in person. We do hope to keep pushing that. We're going to be looking at some schedule changes potentially for next year to see if we can boost attendance. So we'll probably be putting a poll out on our Facebook page to see if y'all might be more interested in evenings or weekends for live attendance as we move forward with this education series. So today we're going to be talking about microbes, the Microbiome Blitz. So many of y'all are probably familiar with, or maybe most familiar with, microbes in relation to gut health, maybe probiotics in our diet. Typically in our lifestyle, fermented foods, beer, wine, and liquor are probably going to be some of the most common, although certainly waste treatment, as well as biofuels, and then probiotics is the most common that we know. So as far as our health goes, aside from just typical gut health, our skin, hair, it's all covered in a variety of different microbes. I think the statistic is somewhere around 90% of the cells that make up our being are actually microbes, and only 10% of them are human cells. Just to put in perspective the quantity and the importance to the organism. So, and all of those things, in the gut in particular, we've got great information that's come out now about how our gut health, and particularly our gut microbiome, can be linked to many other aspects of our health. Psychological, emotional well-being, as well as the function of other organs. It seems to dictate much of our overall health. Additionally, things like body odor, foot fungus, those are all controlled by microbes, and then these all impact largely, in addition to those other things, our immune system and how we fight off diseases. And one thing that's important to realize, and especially this will apply to plants and in the garden as well, is that even if some of these microbes are not beneficial, if they are not harmful or pathogenic, it's good to have them around in our lives, on our bodies, on our plants, in our garden, in our soil, because they're occupying real estate that would otherwise be opened up to pathogens. So that's why, for example, if you go through and do something that's going to destroy microbial life in the garden, or if you take a heavy antibiotic round in your person, it's important to replace and refresh those beneficial microbes in our bodies through probiotics, or in the garden through compost teas, or some kind of, typically foliar spray, or something to replace and refresh those healthy microbe populations, so that we don't have open real estate for pathogenic organisms to come right in. In the soil and in our gardens, one of the most important roles for the microbiology, the bacteria, the fungi, the protozoa, is that they largely control the nutrient availability and the nutrient uptake for the plants in the root zone. Sorry about that pause. I realized I didn't get comments on. We're checking with y'all, so feel free. The comments are live. I see I've got a couple people joined in now, so feel free to chime in. Let me know if there's any issues or if you have any specific questions. So just like in our bodies and in our gut, we can eat certain things that may be nutritious, but if those nutrients are not bioavailable, we are not going to take them up and they're going to be wasted. They're going to pass through our system without actually making it into our body. And that's the same for lots of minerals and micronutrients in the soil. When we put certain organic matters or fertilizers or compost in our gardens, many of those nutrients may not be directly available for the plant to take up in its roots. And it's going to be the bacteria and the fungi breaking down those compounds and making them bioavailable to the plants, usually in exchange for a sugary substance that the plant is exuding out of its root zone. So they control mineral and micronutrient, basically vitamin uptake for the plants in our garden. So it's important that we have a diverse array of those microorganisms and that we keep in mind that we want to minimize the disturbance of them. And if for some reason we need to do some kind of disturbance or cleanup or eradication of some kind of pest in the garden, then once again we need to make sure that we remember to replace those microbes in our system. So in addition to the nutrient uptake and availability, which these are also very interrelated, again, these microbes, not only on the leaf surfaces, but in the soil and around the root zone, also are going to help the immune health of our plants and allow the plant to have its best ability to fight off pests on its own, to produce the compounds it's need to ward off predators. And in some cases, through some of these microbial systems, the plants are even able to communicate through the soil and sometimes send messages about an incoming pest and allow them to boost those defenses. So that's kind of the importance of microbes in a nutshell. So what we'll talk about is the kind of 4 pillars that I always discuss with organic agriculture that guide our system. The primary focus of those pillars is really to preserve this microbial diversity in the soil and to protect that microbiology. So I mentioned that we're dealing primarily with 3 groups: bacteria, fungi, and protozoa. They perform different roles in the soil. As alkaline, and alkalinity in soil is defined by its resistance to acidifying, or its resistance to the pH dropping. And that has a lot to do with the microbial life, which is driven by the organic matter content and the moisture content in our soil. So bacteria in general, when they're consuming organic matter and living in our soils, their byproducts are often going to be higher in pH, and they are going to drive the pH of the soil up over time. Whereas their fungal counterparts, their byproducts are typically acids and are generally going to acidify soils over time. That's why many of the acid-loving species we're familiar with are perennials, and they are found in nature coming from typically more mature fungally dominated systems that are ecosystems that are closer to forests, versus our bacterially dominated systems are going to be earlier in ecological succession, usually closer to post-disturbance, or in the cases of our soil, because we have very little moisture and a lack of organic matter, which that organic matter is a big part of boosting the fungal life. And another important factor is that the fungi typically take longer to bounce back in the system than do their bacterial counterparts. So after a disturbance event, if we go through and say till our soil, we're going to get an influx of bacteria, whereas our fungi are going to be damaged, destroyed, and take longer to recover. So considering and protozoa are a bigger group, excuse me, they're larger in size than bacteria and fungi. They are the smaller macro, well, no, they're still microorganisms, but they're the larger microorganisms. So if you were to look under a microscope at these things, you'd see the small bacterial colonies and little filamentous threads of mycelium, the fungal threads. And then you'd see the little guys, amoebas, and oh my goodness, I can't remember their names. But all of those fun little organisms with the hairs and tails cruising around, those are our protozoa. Often they're performing the last stages of shredding and breaking down those organic materials, and also cycling some of the bacteria and fungi through their systems. One of the big groups there is also nematodes, which some of them will feed on plants, but there's also all kinds of beneficial nematodes as well. Some that predate soil-borne pathogens, some that actually feed on pathogenic fungi, and they actually eat the bad fungi in the soil. So that's another group you're probably not going to consider too much unless you're looking at resilience in the system. So with those three groups, one that most folks in the garden world have become familiar with and we hear lots about now are the mycorrhizal fungi. So this group of organisms are not actually breaking down. They wouldn't be, say, breaking down organic matter in our compost pile, or if you turn over a log, they're not going to be breaking down that woody material. Those are called saprophytic species of fungi. Mycorrhizal species actually have a very intimate relationship with plants, where they grow either in between the cells of the roots, or will actually penetrate the root cells and grow a high surface area organ inside the cell. And what they do is they exchange minerals or micronutrients that they mine from the mineral base of the soil, rocks, sand, silt, clay, and in exchange for sugary exudates that the plants produce, they trade back and forth. And we're under the impression that 90+% of plants need mycorrhizal fungi to grow healthfully. So they're very important in our systems, and again, they are one of the most susceptible to tillage and disturbance. Now, they're widespread and naturally growing. However, they need to grow in association with plants. They don't grow without them. So barren landscapes don't necessarily have them actively growing, nor is your compost necessarily going to have them growing, but they are often going to start growing when you have plant roots in your soil. Assuming you have some native plants nearby and the soil's in decent condition, they're usually around. But we'll talk about a couple strategies, or one particularly easy way to cultivate native mycorrhizal fungi in kind of a soil inoculum that you can plant out with your plants and ensure that you have a good, abundant group of native mycorrhizal fungi. So the 4 pillars of organic agriculture that we like to follow, number 1 is armor the soil. And so that's living plants are the best. If you can pull off a living mulch, that's ideal. But that really means just making sure you don't have barren exposed soil. Organic mulches we use all the time, considering that we're in a dry environment. It's not typically easy or economical to provide living ground covers, although sometimes they make sense in a garden bed. So covering the soil at all times whenever possible, and that can also be with your plant canopy. So if you're transplanting out, you can keep that in mind, but with direct sowing, we're going to want to have some kind of mulch down most of the time. The reason for that is not just moisture retention, but it's also going to protect those microbes from baking out in the sun. It's going to make sure that that mulch layer is that top crust that may dry out, and we'll be able to keep that nice top layer of soil always thriving with microbial life. Number 2 is minimize soil disturbance, and that's tillage. So we try and practice no-till wherever applicable. The maximum amount of tillage we ever do is usually pulling root crops out of the bed. So again, the reason for that is protecting these microbes and disturbing them as little as possible so that they can continue doing their jobs as soon as you get plant roots back in the system, so that there's no lag time where the plant is growing without the assistance of those microbes in the soil. Number 3 is living plant roots in the ground as long as possible. So because there's this constant exchange going on of root exudates from photosynthesis of the plant in exchange for minerals and micronutrients from the microbiology, we want to keep living roots in the soil as long as possible and not pull them out or remove them unless it's necessary. So what that means is when we're finishing a crop that is not being pulled from the ground for harvest, like a carrot or a radish or a turnip, potatoes, anything like that, say a cabbage or a broccoli or a corn stalk, once we're done, we want to cut it off at soil level and we want to leave those roots in the ground. The plant's probably going to die, but we know that many times that plant will start to revegetate and start growing again, and that means those roots are still alive, still feeding the soil, still performing that function, and it's probably not going to be difficult to terminate that crop. We may not even need to. We may be able to just put our follow-up crop in and it's going to overtake that weak vegetative growth, but that soil is still microbially active, so the new crop going in, the new crop that germinates, is going to get great benefit from that. And we're not going to have that lag time from previous crop disturbing our soil or tilling or pulling it out into our new crop. We're not going to have that lag time with the recovery of the microbes. So, and number 4 is crop rotation, and that's one I talk about how we cheat from traditional crop rotation, which is growing different things in a set space season after season, where rather than rotate so much through time, rather than rotating the space, we actually just rotate through time. So in an area we grow tomatoes or potatoes, we're going to grow 2 or 3 more crops before the next season where we're going to repeat a crop. So we're not having that typical winter fallow time or lengthy fallow time in between crops that necessitates rotation for the buildup of diseases and pests and things in the soil. Again, we're getting that diversity of microbial life by switching more, by putting more crops in after that main crop. So we'll follow up with something in the cool season, greens or a radish, something quick for either fall harvest or overwintering. And then once that finishes up, we'll be doing something early spring into late spring, early summer that'll also finish up before we go back to a warm season summer crop. So that's kind of our rotation, and what that does is prevents an imbalance of any particular bacteria or fungi in the soil, particularly ones that may be harmful to certain crops or crop families. So had pretty good success with that up here. We typically always have a little bit of early blight with our tomatoes, which is relatively easy to prune ahead of, and actually seems to be less of it this year than in subsequent seasons. We just have it around where we propagate, and in some of our soil mixes and whatnot. It just seems to be prevalent. Don't know a good solution to get rid of it that would be efficient or economical without sterilizing everything, which is totally counter to what we want to do. But it's easy enough to prune ahead of and doesn't seem to affect our crop majorly, but it is a soil-borne disease, so that's something potentially could get ahead of by rotating, but it seems to be coming with starting with our propagation, and we just have to stay ahead of it. So again, those 4 principles I talk about almost every time we do one of these classes. They really are what guide everything we do, and they're all about protecting the microbes in the soil. So yeah, that's what we're all about. So so now we'll talk about some strategies of what we can actually do to boost these microbes in the garden. Some of the active things that we can do to grow them, grow diverse populations, feed them, and then spread them around, and then keep them going. So one thing I already mentioned is that if there is any kind of treatment needed that kills microbes, almost any kind of pesticide, even if it's organic, is probably going to negatively impact the microbial life of your plants. So you want to follow up with something that's going to boost that. There's products out there that you can purchase, typically called effective microorganisms. Trying to think of other general names they go under. Effective microorganisms can be great products. But really what we want to be primarily focusing on if we want to do this is spraying compost teas. And so to do that effectively, you need to make good compost first. So we're going to go on a little tangent about compost. Not all decayed organic matters are created equal, and not all of them should be called compost. So what we want, if we're going to be spraying in our gardens, is we should be utilizing fully finished, sifted, thermophilic compost. So that's our hot compost pile, and that means a pile that's been well balanced, put together at a minimum size of about 3 foot by 3 foot by 3 foot. The bigger the better, because to get the temperatures that you need for a thermophilic pile, that's about the minimum size to have a sufficient core to get hot and stay hot. A little bit bigger typically makes it quite a bit easier. And that pile's going to be flipped or turned and watered several times throughout its lifetime. You may be able to pull something like this off in a tumbler, but typically they're too small to achieve the heats that we want to cultivate all of these thermophilic microbes. And so you want this pile to be between 140 and 160 degrees for 7 to 10 days. Typically a 10-day minimum is considered safe for manures and putrescent food scraps and for killing pathogens. And also that temperature range for extended periods of time is going to be sufficient for sterilizing most weed seeds and preventing them from germinating in the future. There's some exceptions, cheatgrass being the standout one in my mind and in our area. So that's something to consider. You may not want to be putting all of your nasty weeds in this compost pile. And After several times flipping, monitoring the temperatures, keeping it moist at a moisture level that we call field capacity, which is about like a moist but not saturated sponge, so that if you squeeze it, you can see it's moist and get a little bit of moisture release, but you're not going to be getting free drip coming out. And after that, you'd sift the compost, and then you'd be ready to make tea. So if that's out of your wheelhouse and you're not somebody that's going to be making we use an equal part of Boost to an equal part of homemade compost to an equal part of earthworm castings or vermicompost. So you can also purchase that, and what you do is you get a fine mesh bag that's going to hold almost all of this material. I don't know the particular micron size. You don't want it too small because then the fungal filaments can't make it through. So mesh bag is going to hold most of that fine particulate. I think like coffee filters are too fine, but cheesecloth, anything cheesecloth or looser mesh is going to be sufficient. And you make a bag. I'll post a recipe in the comments, but you wrap your mix up, which we add, in addition to those 3 ingredients, we add alfalfa meal, some kelp meal, a little dry mycorrhizal fungi inoculant, usually about a tablespoon of molasses per 5-gallon brew. And that, the molasses or simple unprocessed sugar, you want unsulfured molasses for this process. And then we put that bag and suspend it in water. We call it our tea bag. And then we'll aerate that, either with a pump that pumps it and makes it splash, or more commonly we just use aquarium aerators with an air stone and pump air into that for 12 to 24 hours. And then you want to use that tea and spray it within the first 24 to 36 hours. You really don't want to let it go, even with sufficient aeration. You really don't want to brew any longer than that, because you run the risk of running out of oxygen in the brew, and that's that's the same with our compost pile. And when we dive deeper into compost, we'll talk a lot about following our nose and utilizing smell to know that you're avoiding those anaerobic conditions, which can often come from overwatering. So now this compost tea brew is excellent for general plant health. It's not to be considered a fertilizer, as it's the microbes that we're brewing more so than any soluble nutrients. But also it's great as a foliar spray. So this is something, after, if we needed to go through and spray for pests, some kind of insecticidal soap or something that we may be concerned it's having negative effects on the microbes on our leaf surfaces, then we can come back immediately after, or as soon after as possible, with a foliar spray of a compost tea, and we know that we're boosting those microbe populations. So another great product that can be added to those brews, to liquid kelp in addition to the kelp meal, and then also humic acid. Humic acid is a fungal byproduct, so that's a great one, particularly for our alkaline soils, and it's got great effects on how the microbes are able to perform that mineral mining or micronutrient mining in the soil on a chemical level or a molecular level rather. So, and the liquid kelp is also, that's one, it does have some soluble nutrition to it, but that is a great one as a standalone, as just a microbial boost, as a soil drench or a foliar spray. That's one of the ones where that one thrives. So I know I mentioned earlier in the year that I was hoping to be experimenting and diving deeper with the Korean natural farming techniques. Unfortunately, some of the preparations failed, and I wasn't able to dedicate as much time as I wanted. But I'll jump into that momentarily, and that's something I'm really excited about getting into because it's a style of farming that, even though it's based out of Korea, it's a natural farming style that's applicable all over the world because it's utilizing what's native or naturalized and around and available at different times of the year and at different stages of growth to specifically harvest not only microbes and boost our microbial diversity, but there's a whole bunch of plant hormone harvesting that's done and utilized to shift plants in their different growth phases. It's fairly complicated. Almost none of the preparations are used by themselves. A few of them, for example, are liquid IMO, which is liquid indigenous microorganism. That would be similar to the product I called effective microorganisms earlier, but these are locally collected via rice in undisturbed native areas, and then they're cultured and expanded, and then you can use that to introduce a wide array of native microbiology into your garden. Another one of the other preparations that goes along with is lactobacillus serum, and so that's going to be the family of microbes that we're quite familiar with as our probiotics. Those are usually lactobacillus and some other species, and they're largely the dairy eaters, and so that preparation is made with collecting airborne lactobacillus or an airborne culture of native microorganisms, and then you select the lactobacillus out by saturating it with milk, and then that's a fridge stable preparation that is often used together with the liquid IMO and other preparations, which is 5 or 6 different herbs that are rehydrated with beer to a state of fermentation and then basically tinctured, and that's put together, and that's more like a the pest control kind of health spray in the system. And then there's several other preparations that are collections of different plants, whatever's locally available, their growing parts or their fruits, depending what you're applying it to and what stage of growth that plant is in. So it's a really great system. I haven't had the opportunity to dive as deep as I wanted. However, that's still on my radar for this winter and to really dive in next season. So hopefully we'll be able to tackle some of that together, and I'll certainly be sharing the journey along the way. So that's a strategy or a style of farming that I'm looking at that's really focused on microbial health in the garden and utilizing that. Another one that's similar is called JADAM natural farming. And it's some foreign acronym, and it's kind of a more wild style microbial fermenting kind of preparation method. So both JADAM and the KNF are really worth investigating if these styles of agriculture or gardening interest you at all. I can't speak to them in much more detail, but certainly worth checking out. So as it stands, we're focused on following those principles and utilizing compost teas, trying to minimize our negative impacts on those microbes. And that's really it. That's really it for us. So Any questions? I know I've got a couple people tuned in there, so I think that's everything I wanted to cover in particular. Feel free to chime in. I appreciate everybody tuning in. Definitely, I know we've still got a few tickets left for our Grateful Harvest dinner. So that's coming up. You can see the details on our page and a link to purchase more tickets. Otherwise, I hope everybody stays out of the smoke and is breathing easy out there. Thanks a bunch, and we'll see you next month.